Okay, so in number 5, they are actually asking us that they're saying find the area of the minor segment formed by the circle of radius 6 centimeter. So that means we have a circle of radius 6 centimeter, okay, 6 centimeter, and they're saying that if there is a circle, let's say this was a circle entirely, we have this complete circle, let's say this is the complete circle with a radius of 6 centimeter. There's this segment formed, okay. Now they're asking us to find the minor segment area. This is the minor segment here. Now, according to this minor segment area, it is formed due to this chord, which is 3 centimeter in length. Now, if we try to plot it outside, what do we see? Both the sides, which are radius is 6. That means what? This is isosceles triangle. Isosceles triangle, what does it have in common? It has these two angles common, like in its characteristic. That means if that's the case, that means whenever we draw a straight line perpendicular to the base, it divides this angle and this angle as equal angles. That means if this is alpha, this should be alpha. Now, if this was initially 3 centimeter, then what should be this length, which is 1.5 centimeter? Because half of 3 is what, 1.5, and we divided it into two portions. If that's the case, then simply we can use this formula or the formula for the SOHCAHTOA. So using sine in this case, sine is equals to, like if this is our angle, okay. So based on this angle, this as the reference angle, what is that opposite length? This is 1.5 and the hypotenuse is 6. So sine alpha equals to 1.5 by 6. Now, why didn't we use adjacent? Because we didn't have the adjacent height, like the adjacent length is not given here. That means our sine alpha is equals to 1.5 over 6. So alpha is equals to what? Sine inverse 1.5 over 6. If you find the value, simply you will get the alpha value. Now, alpha is one of the angle, the half of the angle. We need the entire angle, which is what? Theta. So theta is what? Twice sine alpha? Why sine alpha? Why? Because sine alpha, like alpha was initially, say twice alpha, not twice sine alpha. Theta is twice alpha. So alpha was what? Half of the total, like half of this angle. That means what? The full angle should be twice alpha. If that's the case, they are asking us to find the segment area. Now, how do we find it? Sector is this one, and inside that, this triangle lies, isn't it? So if we somehow subtract this triangular area from the entire sector area, we could find this segment area, isn't it? Now, let's do that. Let's at first find the sector area. Now, how do we find the sector area? We have the formula half r squared theta. So r is given 6, so half times 6 squared times theta is 2 times alpha. Okay, use this formula to find our sector area. Now, we have another thing to find, which is area of segment. This was sector area. Okay, now for segment area, sorry, before finding segment area, we have this triangular area to find. Now, for this triangle, what do we have? We have this theta, and we have both the sides. Now, we know triangular area could also be found like beside half into base into height. We can also use which formula? Half AB sine theta, where AB is the angle, the lengths which are adjacent to this angle theta. So if this is theta, B is the like one of the side and A is the other side. Between two, like between which, like if A or B A or B are the two sides, between them is the angle theta. Okay. Now using this formula, we can simply find the area of the triangle. So area of triangle in this case is half into 6 times 6, because these are actually A and B, and sine theta is what? Sine actually 2 alpha. So placing here the value of theta, we would get the area of triangle. Now, for finding the segment, we have the sector area already found. We've also have the triangular area. If we subtract them, we would get the segment area. So segment area equals to sector area minus triangle or area of triangle. Area of triangle. So sector area is what? Half into, this was in our place, half 6 square 2 alpha. Half 6 square 2 alpha twice alpha minus area of triangle is half into 6 into 6 into sine 2 alpha. Use this formula, just simply place the alpha values in each of the equation, in each of the like expression, you would get the segment area. Okay, this was number 5. Let's see number 6. What do they say? They say the perimeter of a sector of a circle is 20 centimeters. So they have given again a sector of a circle. Now they're giving that the area, the perimeter is given as 20. Now, what do we know about perimeters? Perimeter means length of all the sides, sum of all the sides is known as perimeter. So if this is R, and this is S, the arc length. So perimeter is equals to what? R plus theta. That means, sorry, R plus S, R plus S. That means what? Twice R plus S. Now what is S? Arc length. Arc length is equivalent to what? Arc theta. Using this formula and substituting it in this S, what do we get? P equals to twice R plus R theta. Now they have given us P as what? 20 is given. P is given 20. And in the next stanza, they're saying find the area of the sector if the radius of the circle is 7. That means 2 times 7. 7 is given as the radius here. So if we simply make theta the subject, we would get theta as 6 over 7. Now using this in the formula, sector area is what? Sector area equals to half R square theta. We have half times 7 square times theta, what? 6 by 7. We should get 21 in this case. Okay, this is our sector area. Moving on to the next one, number 7 says they have given us a structure. Let's say this is a square where we have this sector of circle, okay, which touches all the sides, and each side is 10 centimeter. This is A, B, C, D, and this is K and H. Now, AB is given as, or each of the side of the square is given as 10 centimeter. That means this is also 10 centimeter because this is a square. That means all the sides are same. And they're saying this is actually AK is a radius. That means 12.5 centimeter, and AH also actually a radius because this is a sector of a circle. So 12.5 centimeter each. They're asking us to find this angle at first. Then they're also asking us to find the shaded region. It is this area, shaded region area. Okay. Now let's see what would be done at first. They're asking us to find the value of the angle theta. Now, what information do we have so far? Let's see. Let's say, I guess we can solve it in that way. Let's draw this again. Let's draw this in a bigger way. Let's say this is our square. This is our given square. Very sorry for the drawing. This is our sector. Okay. Now, these are equal in length, isn't it? 12.5, 12.5. If this is 10, try to observe what can be understood from this position. Here, if we consider actually this part, let's say this portion, this is like this can be considered as a right angle triangle, isn't it? If this is 90 degree, then if this is our angle, let's say some alpha, this is our adjacent, and this is our hypotenuse, and this is our opposite, isn't it? Let's find our opposite length. Now, why do we need to find opposite length? Because at first, let's think it this way. If this is our, let's say, our like length of the, or like this is our length of the, okay, we don't need to actually find oxygen, like the opposite as well. We just need to find the alpha in this case, because this is alpha, this is alpha. Why? Because this side is also 10, and if this is 12.5, this is 10. Obviously, these two lengths are equal in like size, isn't it? If that's the case, it's easy for us to find this alpha. Now, why am I saying this? Because this length, entire length is what? 90 degree. If we subtract this alpha and this alpha from that 90, we should get this theta, isn't it? Again, think. This is alpha, that is also alpha. Why? Because both are identical. And they're asking us to find this theta. But we know that the angle of one of the side of a square is what? 90 degree. So 90 degree has what in common? Alpha means this alpha plus this theta plus this alpha, both are what? Equals to 90. Equals to 90, isn't it? Because they are forming this side of the square. So that means twice alpha plus theta equals to 90. Now it is possible for us to find this alpha because we need to find this theta. How do we find alpha in this case? We're using SOHCAHTOA. Now we have this adjacent side and we have this hypotenuse. So SOA, SOA, SOH, CAH, and TOA. In which of the thing we have hypotenuse and adjacent? We have cosine, which has hypotenuse and adjacent. So cos of alpha equals to adjacent by hypotenuse, which is 12.5 divided by, sorry, adjacent 10 divided by 12.5. That means what? Alpha is equals to cos inverse of 10 over 12.5. Now we get our first alpha. That means this alpha is also same. Simply, if we just multiply 2i's with alpha, 2 with alpha, and use it in this formula equation, so theta should be what? 90 minus twice of this alpha. Now alpha is what? 90 minus 2 times cosine inverse of 10 over 12.5, isn't it? So we have got our h, a angle a, k. That means we have answered our first question. Now in the second question, they're asking us to find the shaded region area, this area, okay? Now how can we find this? One of the method is, well, not one of the method, there is only one possible method. What can we think of this one at first? Let's see. It is inside this entire square, isn't it? That means, let's see. If we find the entire square, what do we need to subtract like from that square? We have this triangle. That means we can subtract this area of the triangle. We have another triangle. We can subtract that area from the triangle, like from the square. And we also have this sector area. So if we subtract these two sides area, the triangular area and the sector area, we could get this shaded region, isn't it? Again, think. We have this square. If we subtract, let's say if we subtract this entire part, then we could get that shaded region. Why? Because this triangle, both are equal in area, and this sector area, they're the eliminated portion, and that's only the shaded region which is outside of this portion. So that's fine. So we have to find the sector area. We already have our theta in this case, isn't it? We already have our theta in this case. We have theta, we have alpha. Theta is our 90 degree minus twice alpha. And we also have our alpha here. Now, area of triangle. What is it? Half AB sine theta. Now, what are half sine theta? What is our like A and B? A is 10, B is 12.5, or A is 12.5, B is 10, isn't it? Because alpha is our angle in this case. So simply substituting it here, half times 12.5 into 10 times sine alpha. Now what was alpha? Alpha was cosine of 10 over 12.5. Sorry, inverse of cosine of 10 over 12.5. Okay, don't forget to do the inverse and then place it inside our sine. Okay, doing so, we should get our sine alpha, and we should get half times 12.5. I mean half into AB sine theta. This is our area of one of the triangle. That means two of the triangle, like both the triangle has same area. That means what? We just need to multiply this with 2 times half into 12.5 into 10 into what? Sine, and inside which we have cosine inverse 10 over 12.5. This is our what? Triangular area. Now sector area is what? Sector area is half r square theta. Half r square theta. Now what do we have? Half is there. R square is 12.5 square, and theta is what? Theta is, we know, which is 90 degree Oh, wait, it shouldn't be 90 degree. It should be, we have to convert this into our, I mean, uh, in radians, isn't it? So I'm really sorry. This should be actually, rather than 90, this should be 90 divided by 360. That means we are converting it to pi. That means this is 360 into pi. Yeah, 90 divided by 360 into pi, which is actually pi by 4. So pi by 4. So instead of 90, this should be pi over 4. Okay, this should be pi over 4. I'm really sorry. This should be pi over 4. So pi over 4 minus 2 alpha. Okay, this is our angle. So that means here should also be pi minus twice alpha. Yes, pi minus twice alpha. If that's the case, twice alpha, and twice alpha is what? 12 half minus 12.5 square into pi minus 2 times cos inverse of 10 divided by 12.5. Okay, now simply we need to find also the area of the square, which is 10 square. Now subtracting all of them, what do we get? Area of square minus sector area plus triangular area. Okay, this is sector. We have a circular part here, which is arc, and this triangle. That means 10 square minus, we have to add these two like values, which is half times 12.5 square times pi minus 2 cos inverse 10 by 12.5, and add these two. Like simply these two needs to be added, the sector area and the triangular area, which is half into AB in this case is 12.5 into 10 into sine cos inverse of 10 over 12.5. So if I do the simplification, area of square is 100 minus area of sector 0.5 into 12.5 square into pi over 4. Sorry, this is again pi over 4. I'm really sorry. I'm doing some mistakes here. This is actually pi over 4. Pi over 4. There is something here as well. The rest are perfectly fine. So this is pi over 4. So 12.5 into pi over 4 and minus twice alpha, which is twice cos inverse 10 divided by 12.5. And we are left with, we have here, just a minute. So